Good evening, everyone. Uh, Thank you for attending this session. Um, for those of you who didn't see my earlier presentation, uh, this is almost a counterpart or a part deux of what we were trying to achieve by using the ABL to access a product called Securable. So we've called this product Swaggable because it's based on Swagger, and the point of this is to generate OpenEdge libraries and code from OpenAPI specifications. So we needed a ABL SDK. We have a JavaScript Angular SDK as well, and as we're pitching Securable for OpenEdge and PASOE customers, we thought it might be an idea to actually have an OpenEdge ABL library to make it easy to use and fit in easily with any development environment that the OpenEdge guys might be using. Initially, we had it handcrafted, writing our own code, our own classes, and procedures and stuff like that. And it was hard to maintain because every time we added something or took something away or changed some of the models or the parameters that were needed, we had to remember to go to the ABL SDK, modify it, run our tests, and etc. etc. It was also very, very hard to update to keep in line. So what we found that was happening was that we were waiting for a stable, mature release. But that meant, of course, that the SDK fell far behind some of the stuff that we were introducing in the Securable product, and it created inconsistencies in the API. So I hope that most of you are like me, where you look at code that you wrote a year ago, 6 months ago, maybe even last week, and go, what was I smoking when I wrote that? Because that's not the code I recognize anymore. So as time went on, our APIs changed, the format changed, the parameter names and things like that. So we might have had parameters with underscores in, and now they're camel case, and trying to keep that consistent in the API again was really, really hard. So we thought there had to be a better way of doing this. Now, one of the things that we did have was we've written Securable in TypeScript on the back end with Node, and we had an Angular SDK that we could automatically generate based on some of the bits and pieces. So we thought we'd have a look and see what we can do. Now, the Nest.js backend server that we use has a built-in OpenAPI document definition, I think is probably the better way of doing that. So whenever we fire up our Nest.js backend server, the application framework automatically generates an OpenAPI specification based on our endpoints, our controllers and parameters and things like that, which is really, really handy. And OpenAPI has code generators. So there are library generators for C#, for Rust, for Go, for Java, for JavaScript, for Angular, and these automatically create the libraries for either server or client-based clients. You can create server stubs to maintain or generate the endpoints, excuse me, or clients to access those endpoints. And of course, there is none for the ABL, which is one of the common things that we come across with OpenEdge. And so the idea of Swaggable was born. If someone can write stuff for JavaScript, or someone can write stuff for Node or Rust or C, then surely it's not beyond the wit of man to be able to write a SDK for ABL. So what is OpenAPI? Well, it's an API description. It's basically a JSON or a YAML document that describes the REST endpoints of an application. And when I say the endpoints, I'm talking about whether it's a get, a put, a patch, a delete, a post, what the path is to the API, what the parameters are, what the type of parameters are they required, and so on and so forth. And because that's described as in a JSON document, we can obviously then parse that document and do stuff, as it were. The file definition, I much prefer to work with JSON. I know YAML is the trendy, up and coming thing, but that's probably why I don't like Python either, because having a space in the wrong place causes the spec to fail. And I just, my old brain just can't get to grips with that. So I prefer JSON, which is slightly wordier, but it's much better for sorry, much better for me. For my purposes. There is a Swagger UI. So when you have a Swagger endpoint, you can create automatically define and create a form or a UI effectively in the web browser that allows you to try these API calls directly in your browser. Now, the way Securable was written is that everything is an API. So there's no internal DLL calls or library calls that you can't access. So everything the Securable UI does is through the REST APIs, and therefore can also be accessed by Swagger. If you wanted to have a look, if you're masochistic enough to have a look at the specification for Swagger, there's the link there. These slides will be available online afterwards, so we can do that. Here's a very basic, quick view of the UI. It's probably important to say we don't have to write any of this code at all. It comes as part of the Swagger definition from our framework that we use, which is very powerful. The padlocks on the right-hand side are to indicate that authentication is required before you can access this endpoint. So when you click on that, you'd get an authorization token that you enter, and then you can fill in the parameters that are needed here and execute that endpoint. So what were our goals? We needed to be able to automatically generate the ABL code when the API changes. We didn't want to do any handcrafting. We didn't want to have to do any of the issues that we were facing with this. And we also wanted consistency, which is very, very important. We wanted to use the standard ABL HTTP client. And when I say these are the goals for the SDK for Securable. So this is what the generator had to produce for us. We wanted the standard HTTP client because we obviously are or want to be cloud cross-platform with our SDK. We didn't want to have to be tied in with .NET or anything like that. I had to compile in OpenEdge 11 plus. We made that decision because of the JSON requirements within the OpenEdge 10. Between 10 and 11, there were some huge changes which made JSON usable in version 11. We also wanted it to generate the procedure library automatically. We wanted to take all of our models, all of our services, and bundle them up into one simple PL file, which we could distribute. Because we're not using any of the any UI in there, the R code is portable across all platforms. So we could just have one OpenEdge PL file that we could send to anybody who wanted the Securable SDK. We also wanted to use ABL classes rather than procedures, and when we say all the way down, if a model has a property that is a model which has a property that is a model, we wanted to be able to automatically map the JSON coming in from the endpoint into these classes. So it's not just a way of getting data from an endpoint. The SDK must take that data, take the JSON data, and convert it into usable or user-friendly classes that are created and populated. We also wanted to allow customization of service and the model classes so that you could override some of the behavior if you wanted to. And this was to be achieved by creating the base service class as an abstract class, and then having a class inherit that, which you could then override. So if the overriding class exists, we don't touch it. We create it if it does. But the base abstract class or service is automatically generated and therefore will be destroyed every time we generated the new code. So it doesn't matter that you've added extensions or you've added overrides to your top level class, because it's the API that gets wiped out and nothing else. But when we're generating the ABL, we didn't want any manual intervention. We wanted just to be able to fire off the command and have everything added, updated, removed, cleaned out, the parameters updated if necessary, the properties updated, and the models and stuff. As we said, we wanted the HTTP client for the cross-platform support. It's actually documented in OpenEdge, which is nice, so other people can learn to use that. And the request is exposed through one of our factories in the SDK, so you can actually hook into that and add your own stuff if you needed to. So I have actually explained why we wanted the OpenEdge 11 for the class and the JSON support. We use something called PCT to compile the code from Julian. It's a fabulous little toolkit, which we'll come on to. And again, because we wanted the procedure library automatically created to ease the distribution and stuff like that, we use PCT to generate the prolib as well. So there's several technologies that we're using here to build, to parse, to compile, to distribute, to deploy, and so on and so forth. PCT is a wonderful tool. If you haven't used it, it's fantastic for your DevOps automation. Code completion in Eclipse is important for the ABL classes. So one of the benefits of using classes for the SDK was, as a developer who's wanting to integrate our product into yours, being able to just start typing and have all the code completion appear automatically in the library is in the editor is really important for us, and classes allowed us to do that very, very easily. The customization, as we mentioned, is also important, because there may be some reason that you want to intercept a certain method and either manipulate the data before or after it's sent or received. So you could strip out some JSON fields or some properties if you didn't want them to appear in the payload. So this allows you to be able to customize the HTTP call before or after without actually running into problems then when we generate a new version. Technology. We use Docker for almost everything that we can possibly do, because it just makes life so much easier for all sorts of things. So our generator is using Docker, which is based on Ubuntu, which has then got a Node image laid over the top of that, and then an ABL image laid over the top of that. When you map in a configuration file or a progress config file, you can actually then use or install, for want of a better word, a complete OpenEdge platform without having to go through the process of installing OpenEdge. Obviously, as long as you've got the appropriate progress.cfg file, we can map that. Now, that's not to say that this product or the SDK here is or requires Docker. We're just saying this is what we use to build our SDK, because it makes life a lot easier. We use Node as the runtime as a program that does this, and we parse the OpenAPI spec with this product here. So this produces services and models in TypeScript. We then parse those models and services in a product called TS Morph, which is a code analyzer. And again, we'll go over some of that, some of the reasons for that in a couple of minutes. Nunjukt is a funny term, but Nunjukt is the templating engine that we use for TypeScript or JavaScript that allows us to easily produce code on data that's passed into template engine. And we use that to produce our ABL models and services and code. I mentioned PCT before, that it compiles our code and the library. So we have one image to rule all for Docker. So we build an ABL image based on a Node image, which is based on an Ubuntu image. So at the end of the day, we have the 3 images put into one that then allows us to be able to run ABL and Node on a single image, which is basically a self-contained development system. So we could push this up to the cloud. Someone could pull it down. Someone on our team with a valid progress license could pull it down onto their box and fire up the SDK generator. No dependencies at all. Okay. So why didn't we write the generator in ABL? I did that several years ago. Some of you may remember a product called Maya, where we developed a Ruby on Rails type active record system for Progress, where we automatically generated the classes and models and services required to access the database in a fluent method. And it was tricky, to say the least. And as I've got older, as I've become more mature and probably more lazy in my coding, if there's a tool that does the job better, I'm going to use that tool. I'm not going to say I am OpenEdge all the way, baby, and try and hit a nail in with my shoe, for want of a better term. So the right tool for the right job. The ABL string manipulation is rudimentary. It's not the best substitute. At some stage, I'm sure someone's tried to say substitute &10 and wondered why it didn't work properly, and you had this odd 0 at the end of the first parameter. Well, yes. JSON manipulation is rudimentary, long-winded, very complicated. And whilst it's all possible, again, as I say, the right tool for the right job, I needed to get this done. We needed this out, and to write it in Progress would have taken it'd take me down a different path. Now, obviously, all of us use OpenEdge and Progress for the thing that it's really good for. String manipulation and JSON manipulation is not the best. We didn't use TypeScript because it was faster. It is. But when you're looking at code generation taking a second, it kind of is pointless trying to make it faster. because I'm not sure my team would be happy with the fact that I made it 0.5 seconds instead of 1 second when they run it once every week. I'm not sure it makes that much of a difference to them. So TypeScript and Node, we use this because there's many OpenAPI parsers written in TypeScript already. And as I said, I'm not going to take the OpenAPI definition and specification and write my own parser. I might as well just use something that's already there. And there's an excellent TypeScript parser called TS Morph, where again it's an open source language parser where you can feed your code into this parser, and it's got lots of helpers, which makes things very, very easy. And obviously there's lots of templating engines also available in TypeScript and Node. The OpenAPI TypeScript CodeGen product, which is quite a mouthful, or OTC, produces the services and models for us, one type per model. So this is what we wanted, because one of our goals was to have a class per file because of the Progress OpenEdge class definitions. TypeScript, for example, allows you to create multiple classes per source file, which obviously Progress doesn't. But this product produces how we wanted to do it. So on the left here, we have the OpenAPI spec, and on the right, we have a model that is produced by the OpenAPI parser. And you can see from on the right-hand side, it's not that dissimilar to Progress classes. You're importing instead of defining a variable. You're exporting a type instead of making the class available. The question marks in the properties are for optional parameters, and obviously array and device and stuff like that. So TS Morph is the open source parser where you can parse, manipulate, and emit code. Really, really useful for all sorts of things, not just being very nerdy and geeky and having a look at your code and wondering what you can do with this thing, but actually doing some proper work. For example, where you can rename a variable or rename a method and have it automatically refactor that in the entire code base, and only that. So one of the problems you normally have with search and replace is that it replaces stuff you probably didn't want replaced, and you wonder why your error messages are now coming up with some strange text in there because you did search and replace. So we're using TS Morph to parse the generated code because it's easier than traversing the tree of the OpenAPI data. And here's an example of something that you can do with TS Morph. So we're renaming the method operation ID. I'm getting the source files. I'm looping through each file of the source file. I'm loading all the classes of that file, and then running through the methods of each of that class and renaming according to this parse operation ID. Now, it's just an example of the code. It's not actually working code. I stripped this out of something just to show you actually really how easy it is to be able to parse and manipulate the structure of a TS file, almost as if you're reading database records from OpenEdge, which is really handy. So Nunjukt, that's the website for this. It takes JSON data and then merges it into a template that's been defined. So you can either do it as a straight replacement, i.e. just replace this variable with these contents. You can also put logic and functions and conditions into the template. So you can do loops, you can do if then else's, and stuff like that. So it's basically almost like a little programming language in its own right within templates. It's extendable, that you can plug your own functions in to generate your own code as necessary. And the real reason we're using this is because it allows you to define your own templates rather than having, if something's defined in your program, you're going to say, output string def var a as char, the template allows you to define that in a customizable format. So now an end user might not like the way that we generate our SDKs and models, but the fact that they've just got the data, they can now use a Nunjukt template to produce whatever files they want, which is really handy. So here's an example of the Nunjukt model template that we have for the OpenEdge class. Line 3, SDK path.models. So that's where the SDK is going to exist. And we've got the class definition with the prefix and the class name. So SDK path, prefix, and class names are JSON objects that are passed in there, or properties of a JSON object. And you can see line 6 there, we're doing a for each property in properties. So what that's going to do is just loop through all the properties that are defined in the JSON and declare a public property as that name, as that type, with a no undo get set. So if you wanted your properties to have to not have no undo, you would just modify that template and take out the no undo, which makes customization really, really easy. Progress compiler tools, again, that's where you can get them from Riverside. Gilles has done a fantastic job with that. Great tool set. So we're using that to generate the code. Now, this is the output that we have after running this. You can see on the left-hand side all the models that we have. So every endpoint or API endpoint that we have has input parameters and a response. Most of them. They may not have a response, they may not have input parameters, but this is the basic thing. So we create a class or a model for every payload and every response. And so, for example, the Sable user class that we're showing here, it's got user groups, and you can see that we've got another model as the data type for those user groups with a variable extent, because we don't know how many user groups this user belongs to. And this is automatically populated by the JSON data when it comes back. So we've got the various names and description, color, connectors, etc. within there. This is an example of the service that we create. Line 21, you can see we're creating a user. We're having data input as a class. So if you're using this SDK, you populate the Sable user payload model with properties, with data, and just pass the model in as an input parameter to the create user method, which then goes and does its own thing. So you can see line 34 is the JSON counterpart of this, where it then actually creates the options for the HTTP class, does the service, which posts to V1 users, passing in the data, and converting the response back into the data. So line 43 returns JSON back to line 30, which then converts that JSON back into a class. So the create user class method, returns a Sable user model property back. So you get an instance of a class back rather than having to parse your own JSON, which is rather handy. And you can see here from this is an example of something using the SDK, where we're defining the result as a login response. We're creating the login payload, a new login payload, and then passing in the username, password, calling the login service, the login method, and you can see our result there on line 19 is our token. So that's the secure token, which is generated from the SDK. And there's our login response. So you can see line 6, that's where our token is. And our login payload, which is the username, password, etc. And finally, the login service, which performs the task. So some of the challenges that we face, OpenAPI allows you to have a response that can be different based on parameters that come in, which I don't like, but unfortunately it's one of these things that we have to cater for. So a parameter could be one of, or all of, or any of these things, which does give us some challenges in OpenEdge, where we're looking at see how we can do that, probably through JSON objects rather than that, because if it's this can be A or B unless we know how to differentiate A and B. Maybe there's a property that's only common between two classes, is not common between two classes. You could then, in the override procedure, decide which value to return. We currently only support OpenAPI v3 because of some of the options in there. We may consider v2 if the demand, because there's a lot of APIs that are only v2. Obviously, you need your development license to compile your generated code, but as OpenEdge developers, I would expect that you are compliant with Progress's licensing procedures and requirements. We're having support soon for the required options, so we can automatically generate code that would throw out a payload if it doesn't have the required fields, whether it's nullable or not nullable. Again, so we could put error handling in automatically to say if a property is coming through that is null or not null, depending on your requirements. Query parameters, yeah, I forgot about those, so I'm putting those in. Different authentication methods. Currently, because Securable uses the bearer auth, that's the one that we use. And there's a security requirement object, which actually the definition of the OpenAPI of the endpoint includes a list of the ACLs that are allowed to access that list. License, it's currently closed source for one good reason. The code is not fit for consumption without embarrassing me at the moment, because it's been put together in a way that could be better and will be better. So when the code has been tidied up and when we've done a couple of little bits and pieces, we will be putting it as this SDK generator as open source on GitHub. Now, one of the nice things about the fact that it's an OpenAPI generator is one of our test suites that we are now running is to generate an ABL SDK based on the GitHub OpenAPI, which is interesting because it makes a lot of use of a lot of edge case type stuff. But when that's done, when that reference SDK is generated, we will be able to access the GitHub API directly from within our OpenEdge application, which could have some cool possibilities. As I said, there's lots of other OpenAPI stuff out there. I've slightly overrun, only by a couple of minutes. I know it's the end of the session. Running the code is literally build and you get the output. There's not much to show. It just does its job. So I'll stop there. Obviously, if anybody's got any questions or any wants any follow-up, please feel free to contact us and get in touch. So I don't know if there are any questions.
I didn't receive questions in the chat, so no.
Excellent. So we can all go and have some dinner, which would be nice. All right, guys. I appreciate you all attending the session, and for those of you who are watching it later,
there's a question coming in.
Oh, Excellent.
Does this mean that this tool, when it generates JSON, removes all progress-specific properties? That's a question from Vivian.
It removes all progress-specific properties.
That's what it says.
Not entirely sure what that means, but we do take the an inbound JSON and map it to the SDL, the ABL properties. So if there's a ABL property that's a JSON property that's a reserved word, there is a mapping ability, so we can rename it to another property automatically. So let's say a field is called rec ID, and that's a reserved word. I don't know if it is or not, I can't remember. But we'll be able to, in the SDK definitions, be able to say that rec ID maps to O rec ID in OpenEdge. But when it gets received, it converts rec ID to O rec ID, and when it gets sent out, it converts it back the other way.
Okay, Vivian is adding more details to her question. So when I serialize a class as a JSON object, it's wrapped inside some progress properties. Does that help to answer?
Sorry, could you read that again?
When I serialize a class as a JSON object, it's wrapped inside some progress properties.
Yeah, we don't do we don't use the serialize option of OpenEdge. Because we're writing the code generator, we can map out line by line, property by property, the OpenEdge class. So when we receive a class, we actually create the JSON directly from each property on a line by line basis. So there's no need to serialize or deserialize.
Okay, so that seems to have helped Vivian because she thanks you. And Tim is asking which API call gets me that. That is maybe the hard part.
Which API gets you what?
Yeah, that's so Tim, if you can be a little bit more precise what you want, I think you can answer that.
There is a it depends on the, if you're talking about the
Our Tim
OpenAPI.
is asking where he gets good beer. So
where he gets my beer, I can tell you that.
Yeah.
I have several websites. Tell them to contact me offline, and I'll send them all sorts of brewery links.
Yeah. All right, I think that's it.
Excellent. Okay, thanks a lot, guys. I appreciate that.
Yeah, thank you very much. And yeah,
and thanks for your help today, moderators. It's been helpful, really useful.
All right.
Okay, thanks a lot, guys.
Bye-bye.
Bye.